AMC 10 2021, problem 12. We have two right circular cones with their vertices facing downwards. We have water levels within them, and the volumes of them is the same. And we're trying to find the ratio of the water level rise given that we drop a sphere of radius 1 into the mix. So before we even find out anything, we want to find out the proportionality between V1 and V2. Why? Because if we find out proportionality between the volume, we can find out proportionality between everything else, from its side length to its height and etc. So to find the volume of a cone, that would be 1/3 its base times its height. So how do we find the base of V1? V1 will be equal to 1/3 times its base, which is base area, which is pi r squared, so 9 pi, times its height, which is h, and then V2 will have 1/3 times its base area, which is 36 pi, times its height, which is h1. Simplify, we get 3 pi h. Simplify, we get 12 pi h1. So establish a proportionality between V1 and V2, we get h over h1 times 4. So therefore, the volumes between V1 and V2 will be 1 to 4. So therefore, we can establish proportionality as 1 to 4, as so. Now, given 1 to 4, what can we say if we drop a sphere into this mix? Well, if we drop a sphere, we can imagine it for these two cones for the water level to rise by a factor of h. I'm going to call this h2, and I'm going to call this h2. Now, I don't really care about the two heights because all I know is that since the volumes of the two spheres are the same and that they will grow at a proportional rate, that means that no matter how much volume that we add into both spheres, it will not alter this proportionality because we're adding in the same sphere. Since we're adding in the same sphere, we are adding in the same volume. Since we're adding in the same volume, we are not altering this proportionality. So therefore, the proportionality of 1 to 4 of V1 to V2 will remain constant. But what do we want from the question? We want to know the ratio of the rise of the liquid level in the narrow cone to the rise of the liquid in the wide cone. So what is the narrow cone? The narrow cone will be V1, the wider cone will be V2. And since we find the ratio of these two, that will obviously be answer choice E, and we are done.